Okay. So I just left this small when I scanned it. We don't really, this is what I want y'all to be focused on, right? So we're talking about the characteristics of different squares. So when you think about the difference of two squares, what are we looking for? When we see that polynomial, we know that we can identify it because it has what? It has two terms. Yeah, absolutely. It has only two terms. So I'm going to write that because I think that's important. So two terms compared to like a trinomial. What do we call a polynomial that has two terms? Very good. It's a binomial. Okay. What else are we looking for? What are those two terms look like? Those two terms are, what do we call those? Perfect what? So the two terms are perfect squares, or so the two terms are perfect squares, or they have a GCF and then perfect squares, right? We can take out a GCF and then we have perfect squares. Okay. So if we have two terms, and there's something really important about those two terms. So we know that those two terms are perfect squares and they're joined by a what? A minus sign. Yeah. The two terms are joined by the subtract or subtraction sign. Okay, that's why it's called the difference. Remember that the word difference means subtract. So we have the difference of perfect squares. I'm going to leave that up there for a second. I'm going to slide us down and get us ready for the next one. Raise your hand if you need that up there for a little bit longer. We good? Okay. So what are some of the steps for factoring? When I think about having difference of squares, how do I factor it? What should I do first? We call it the number one rule of factoring. Travis, I see you have your hand up. Are you stretching? Yeah. What is the number one rule of factoring? What do we always look for first? Say, yeah, we look for a number, we look for a GCF. So the first thing that we always want to do, always look for a GCF. That is the most important thing that we can do when we're factoring. Okay. So the first thing that we're going to do is look for a GCF. So we've gotten rid of our GCF and now I have two perfect squares. How do I factor that? Say that again. Is that what you said? You guys are whispering. Say it loudly. Not yet. We don't slide and divide because we're not going to slide and divide these. Oh, is that what you said? Yeah, we have to take the square root of each term, right? Because these are perfect squares. So we have to take the square root of each term. We have to take the square root of each term. So I'm going to put an example here. 4x squared is my first term. Let's see what number. Remember, you have a chart of perfect squares that should be in your journal. What number multiplies by itself gives me 4? 2. What number multiplied by itself gives me x squared? Good deal. Okay. And what if I put a 9 in the other one? What if my other term was a 9? What number multiplied by itself gives me 9? Good job. So I take the square root of my two terms. Okay. God bless you. And then what do I do with my two terms? Well, I'm going to write them as binomials. So I'm going to write it as two binomials. One of them gets a what in the middle? A plus, and the other one gets a minus. Doesn't matter the order. No. Doesn't matter the order. We're going to join them as two binomials. One gets a plus, the other one gets a minus. Okay. So we have 8 examples. 8 examples. Raise your hand if you need more time for this top part. Okay. All right. So our first example, that's really not 1.81. I need to put a little bit more space there. This is like 81 m squared minus 36. Is 81 a perfect square? Is that on your dark pink perfect square chart? Okay. So I need to take the square root of 81 m squared. And I also have to take the square root of 36. All right. Bailey, square root of 81 m squared. Look at your journal. You guys have a perfect square chart. Look at your journal. You have a perfect square chart. Square root of 81 m squared, Bailey. And then what about my variable? 9m. Yes, ma'am. Square root of 36, Brian. 6. Okay. So when I factor these, I have 9m plus 6 times 9m minus 6. Do y'all see anything that looks funny? Yeah, these have a GCF. So remember we talked about this. If you factor and you see that your factors are still divisible by a term, that means that we should have taken out a what at the beginning? A GCF. Mrs. Bischoff did not follow the number 1 rule, and you let me do that. What is my GCF here? 9. We can divide all of these by 9. So I'm going to take my 9 and drive it straight downstairs. Put that in the bottom. All right, so that gives me 9m squared minus 4. Square root of 9m squared is 3m. And the square root of 4 is, Uriah? Join one with a plus and one with a minus. There we go. So remember, if you have a GCF and you forget to take it out, all is not lost because you can recognize it at the end. You could divide at the end. Is that what you're saying? Yes, we could have taken a 3 out of each term and then remember to multiply those together. Absolutely. Good job, Kimber. Okay, number 2. Is there a GCF there? Yes. 9. Does 64 divide by 9? Yeah, what is it? Let's see, 9 times 6. 9 times 1, 2, 3, 4, 5, 6 is, I get 54. Okay, so no GCF. So let's do the square root of 9, m squared, and the square root of 64x squared. All right. Delilah, what is the square root of 9? Yeah, 3. So that's going to give me a 3m. Carla, square root of 64. Awesome. 8. So that's going to be 8x. Jansen, you feel like you can tell me how to write the product of these two binomials? What am I going to do? No? Okay. Kaden, you feel like you can write it out? What did you get? What's your first term? So 3m. You have to join one with a what and one with a what? What two symbols do we need? Okay, so let's do 3m plus, what's your last term? 8x. Okay. And then 3m minus. Good job. Do you guys remember why this works? Why does this work? Why does 3m plus 8x and 3m minus 8x only give me two terms when I FOIL that out. What happens when I FOIL this out? What is 3m times 3m, Aiden? 3m times 3m is? Perfect, 9m squared, right? If I do 3m times a negative 8x, 3 times 8 is 24. So I get a negative 24 mx. I take my positive 8 times 3, I get a positive 24 m times x. And then a positive 8x and a negative 8x, 8 times 8 is 64. A positive times a negative is a negative, x squared. What happens to these two terms in the middle? They cancel each other out. Yeah, that's why we have opposites. That's why one's joined with a plus and one's joined with a minus, okay? All right. This one is tricky. This one is tricky. So is b to the fourth power a perfect square? How did I make that? What two numbers? Think about your exponent rules. What two numbers did I multiply together to get b to the power 4? They have to be the same. I know that if I take b to some power times b to some power, I'm going to get b to the fourth. What is the exponent rule? You add the exponents. Yeah, if the bases are the same, you have to add the exponents. So it has to be the same exponent, right? Because they have to be the same number. So what number added to itself gives me 4? Yeah. So when I take the square root of b to the fourth, I actually get b squared. What is the square root of 16? Anyone? 4. Okay. So let's see. If I use the rule, it says you take the square root of the first term added to the square root of the second term times the square root of the first term subtracted from the square root of the second term. But when I look at this, why is this one tricky? What do you see for that last binomial? What do I have there?
No, wait, no.
What is b squared? Is b squared a perfect square?
No. Good, yes, it is.
It is. And is 4 a perfect square? And are they joined by a minus?
Yes.
Oh my gosh. So that means that this first term is all the way factored, right? Because we can't factor a sum of squares. But this one can be broken down again. We have to break this one down again. Okay, this is what it means to factor completely. This is a tricky one. Some of you guys got this far on our matching puzzles that we did on Friday. So I really have to figure out what the square root of b squared is. What is the square root of b squared? What? B, yes, sir, thank you. And what is the square root of 4? 2. So one gets a plus and one gets a minus, and I'm just going to put this one right in front of it. So I have b squared plus 4 times the quantity b plus 2 times the quantity b minus 2. That's higher level thinking, right? That's a serious type of question because we know that we have a power of 4 there. This is a 4th degree polynomial. What about example number 4? They are both perfect squares. You are exactly right. Amalia, look at your 6.8 notes and tell me what that special note is that we wrote at the bottom of our page. What is the special note? If you look at your note packet, 6.8, there was a great big special note that we wrote at the bottom. Go over one more page. There you go. What does that say down there in that great big arrow? Yeah, what does it say in there? Yeah, the sum of squares is not factorable. Is this the sum of two squares or is this a difference? This is a sum. Plus sign means sum. So the sum of two squares is not factorable. It is not factorable. Okay. Number 5 is exactly what we've been doing. The only difference is what's happening here. How does this one look different? Tiana, what did I do for this one? How's it different? What's first? Instead of the variable coming first, what happened? Yeah, I put the number first instead of the variable, but it still factors the exact same way. Number 5 still factors the exact same way. So I'm going to let someone give me their answer. Kimber, how are you going to factor number 5? Perfect. What is the square root of 4, ma'am? 2. So I'm going to have 2 and 2. And what about the square root of s squared? Perfect. What do you want me to join those binomials with? Absolutely outstanding. Okay. Number 6, Ashton. Ashton, is that the difference of two squares? Is it? Is there a plus in there or is there a subtraction sign? But tell me about your leading term. It's negative. Yeah. So what does that mean? Can you leave your leading term? Is there any way for me to multiply a number by itself and get a negative answer? Meaning, can I take 5 times 5 and get negative 25? No. Can I take negative 5 times negative 5 and get negative 25? No. So the only way that can be a perfect square is if I get rid of the negative. How am I going to do that? Yeah, I have to divide both sides by -1. So that negative is essentially a what? What am I doing with it? I'm going to drive it right downstairs. What is that negative actually? I need someone to say it or we can't move on. It's a GCF. That -1 is a GCF. Negative 25 divided by -1 gives me a positive 25. Positive m squared divided by -1 gives me a negative m squared. Ashton, I'm going to come back to you. So now do you think you can factor that as a difference of two squares? Yeah. Okay. So it's the square root of 25. Perfect. And the square root of m squared? Perfect. What do you want me to put in the middle of those two binomials? Perfect. Don't forget your -1 that you took out, right? That's still part of your answer. That's why we put it right downstairs. If we don't drive it all the way down there, we forget about it. Okay. All right. Jansen, I'm coming to you. Jansen, I'm coming to you. Talk to me about number 7. Do you see a GCF? It's a variable term. What is it? What is it? Number 7. What's the variable that's being repeated? B. So I have to take that out. I have to get rid of that B. So we're going to take out a GCF of B. We're going to divide both things by B. So I'm going to take that GCF and move it all the way down to the bottom. All right. So B cubed divided by B is B squared. And -4 divided by B is just -4. So Jansen, now I have the difference of two squares. How are we going to solve that? It's going to be just like we did in number 6. So what do we do first? We put that little box symbol over this, what, right? Do you see that? We did this first. What's that called? Square root. Yes, Justice, square root. So we're going to take the square root of b squared. That's all right. So what variable or number do you multiply by itself to get b squared? 1b, right? 1b. Okay. And when I take the square root of 4, what do I get, Jansen? 2. And what do I have to put in the middle of both my binomials? A plus and a negative. Good job. Okay, our last one has 2 variables. Watch out for this one. Watch out for this one. So, Gianna, I see your hand, Violet. I'll call on you if Gianna doesn't have the answer, okay? So, Gianna, what would you like to do first? Divide by what? Divide by 9? Is that what you said? Good job. So, Gianna's saying, hey, there's a GCF of 9 in there. There is a GCF of 9. You have to take that out first. So when I do that, I have now 9f squared minus 1r squared. Okay, keep going. You're doing great, ma'am. So the square root of 9 is 3. What about f squared? What do I do with that? It would be f. Good job. So 3f. Yep, the square root of 1 is 1. What about r squared? So is it okay if I don't put the 1 in front of my r? Are you guys okay with that? Okay. What do you want to put in the middle of my 3f and my r? A plus and a minus. A plus and a minus. Okay.